Welcome to Insight Builder channel, exploring Pytorch on Raspberry Pi, hands-on tensor data manipulation for AI enthusiasts. This is a part 2 video on multi-part series where we are looking at the methods and functions inside the Torch module. We had looked at the various ways of initiating tensors using these functions, and in this video we will be looking at these functions. These functions will help to work with multidimensional vectors, tensors, and also we will look at a couple of these functions also, like cat and stack, in this discussion. Apart from that, I would also like to discuss a bit about VS Code alternate. The reason why I'm discussing about VS Code alternate is the VS Code server that gets installed in Raspberry Pi takes a considerably large amount of RAM. So I will show you what I mean by the large amount of RAM. So if you take a look at this particular htop function htop command output, you see there is 322 MB of RAM that is getting consumed. And at this moment, I am using the Jupyter server that is running. So that's why it's taking this much. If I am going to run VS Code server, so if I use the remotes in this VS Code server, there is high chance that the memory will get completely used up. So after a lot of checking, then I realized, okay, it's better to use Jupyter server with NB extensions. So I'll be showing you how to install the Jupyter notebook, and that is Jupyterlab, and then install NB extensions. So first we start by installing Jupyterlab. So all you need to do is do a pip install Jupyterlab. It will start the Jupyterlab installation and it will complete in less than 5 minutes. Once you are done that, the next command that you're going to use is going to be the NB extensions. For that, you have to use this particular command. Sorry about that. You have to first of all install the Jupyter Notebook NB extensions. So you have to do a pip install Jupyter contrib NB extensions. These commands I'll be sharing it in the YouTube description below, video description below, so you don't need to worry about it. Once you have completed this Jupyter contrib NB extensions, then you need to actually downgrade the notebook, because the notebook 7.0.6 has some challenges when it comes to enabling the NB extensions. So after looking at Stack Overflow, I found that if you execute this particular command and downgrade it to notebook 6.4.12, then it works without any issue. After you have downgraded, then you have to enable the NB extension for the current user that you're running. So Jupyter contrib NB extension install --user will do that. It will do the necessary configuration for you. After all this has been completed, then you have to enable this Hinterland extension. So I'll be explaining right now the reason of Hinterland. What happens is, the main reason why I chose VS Code and why I chose to work with the VS Code Python script is that you can get the AutoCompletion as well as you can get the various code related and function related information help on as you are typing in the script. However, because of the challenge that I told about the VS Code server, I had to find an alternate with Jupyterlab. So that's when I came across the Hinterland extension. After you have done all the installation with the above commands that I have provided, you have to start the server. Since you are going to start the server inside the Raspberry Pi, which does not have a display. So how are you going to look at the browser and how are you going to connect with it? So you cannot do that. You have to create a server which does not open in the browser directly inside RPI, but it can actually help you to connect from outside, that is from Windows, from your Windows browser. So for that, you need to run this command. So you have to use nohup. Nohup is a command in Linux which allows you to run the server at the backend. So there are certain commands or certain servers that take control of the terminal. If you use nohub, then it will leave back the control of the terminal. So that is the purpose of nohub. And you have to say Jupyter lab, and you have to say double hyphen IP. You have to give 0.0.0.0. This ensures that the server runs on all the IP addresses inside the server, meaning inside the Raspberry Pi. So why we have to do this is, if you run it on 127.0.0.1, then you have to create a separate tunnel to connect with the Jupyter server. But if you're going to use this IP option, then you don't need to do that. So that is the primary reason why I am doing this. After this, we need to still say no browser, and we have to say the port is going to be 8888. Then we are going to use this symbol to redirect the output to the Jupyter log. So we have to create a small log file, and after we give the log file, we have to press the ampersand key. Only when we do this ampersand key, the entire process goes back into the background processes, or else it will be in the foreground. So you have to press the ampersand key. Once you do this and once you press enter, the server will start. Since my server has already started, I am not executing this code. If I do a cat on Jupyter log, you will see that my server is already up and running, and it has connected to various kernels, and the server is running in this particular location, in this particular URL. So if I click on this particular URL, this particular output will happen. So torch it 8888 and the lab will get opened. After that, you can start creating the new console, because we are going to work on the console. We are not going to use the Jupyter notebooks. Also, we are not going to use the scripts here, because scripts, as I told you, in this case, if you are going to go for the scripts here, it will be a simple text file. So if I go for Python file, this will be a simple text file, and even if I do import, it will not have any kind of auto completion. So it does not serve our purpose. So I'm going to close this, discard, and what I'm going to do is I'm going to work on the console. To your benefit, console actually has auto completion option. So once you use import torch, the torch will get imported, and if I say x equal to torch, and if you press tab, and sometimes even the tab is not required if your system is really fast, and you will see that the auto completion starts working. So if I say tensor, and if I open it, and there are a couple of settings you need to modify. So go to the settings, click on settings editor, and in the settings editor, you can change a couple of things. Go to the terminal, change the font size, change the font family, make the terminal theme dark, and go to the code console, same way, change the interaction mode. So if you want to make it as terminal, make it as terminal, or keep it as notebook. And you can also modify the theme, etc. there. And if you want to modify the font size, you can do that in this location. You go to the notebook, just a minute. Yeah, you can modify the tab size and the font size here. You can do all this. Also auto closing brackets you can initiate here, and these are the various things that you can modify and keep it ready, so that the console that you're going to work is pretty neat. Now that we have got the tensor here, if you use shift and tab, you will see the entire help of the tensor comes out along with the example. This actually makes your life extremely easy, I'm telling you, especially when you're going to work with torch, I mean the torch and related modules. Having this kind of pop-up coming up with the help and the doc strings actually changes the way you practice. The more you are able to do this kind of practice and work on various kinds of problems, you will start mastering the concepts really fast. So now that we have completed the basic setup in less than 10 minutes, what we are going to do is we are going to start working on the pending methods. So the first method that we are going to look at is called as arange. So arange, and once I do that, I'm going to say this. So here we see there is a start, there is an end, there is a step, and there are various other kinds of things that you can provide. But the most important thing is start, end, step, and d type. So I'm going to say start equal to 0, end equal to, let us say, 25, 27, step equal to 1. I'm going to keep it. All these are pretty constant things that we can work up with, and I'm going to say I'm going to execute. In case of executing the notebook related commands inside this console, what you can do is you have to press shift enter. Once you press shift enter, that will get executed, and you can see that tensor has been created. One of the benefits of using the console is that you don't need to import Torch again and again. As you saw in the scripts in the earlier videos, importing Torch module takes a bit of a time, and in RPI it is going to take a little more time also. Just to give you a glimpse on what is going on the RPI, let's go back and look at the htop to look at the value of the RAM. It's around 332 MB. We have left around 600 MB of RAM to work with our various activities, and among this 300 MB, only 75 MB is being used by the system, that is the PyOS. Rest is all used by the Jupyter server. Still, VS Code was using more than 600 MB. Compared to that, this is way better. And if you're going to look at the VC Gen CMD and measure temperature, you'll see that it's at 52.6 degrees. And if you're going to run VS Code server, it is going to be at 60 degrees Celsius. So looking at all these trade-offs, I felt that using Jupyter Notebook is a better choice for not just for our ease of work, but also for the safety of the Raspberry Pi. Okay, that's aside. Let us now look at the arange data type. We have not given the data type here. So if I do a print, we have not given the data type when we instantiated this particular arange. So if I do a print, I don't think we need to do a print. If I do a type here, you will see that it is a long tensor. But if I initiate the same tensor with the d type of torch.float 32, then what will happen is it will actually create a type of float. So float tensor basically. So you'll see that it's creating a type of float tensor. You have to keep in mind that there are half tensors also. So let us actually make it as 16 and let us execute it. You'll see it's a half tensor. And let us see what happens if you're going to give 8. And you'll see there is no attribute called float 8. So why is this happening? So let us take a look. So when you are going to do a torch, and if you're going to run float, you will see that there is 16, 32, 64. But after that, when you're going to go to float, there is a different kind of float types. So that is E5, M2, E4, M3, Fn. So these things you have to take a look. And there is B float 16 and there is C float. There are lots of different types of floats available, because floats are the key when it comes to neural networks. We will be diving into these things as we go further into the discussion of neural networks. So stay tuned. We are right now going to go with float 16, which is actually a half tensor, right? You will be coming across these half tensor and various other kinds of tensors, full tensor, long tensor, etc. when you are facing errors. Because as we go forward with various kinds of tutorials, and you might actually download the data from any source, and you might want to start working with it. At that time, you will face these kinds of challenges because the data type is very, very important. Okay, now the arange has been done. Next, what we are going to do is we are going to work with the triangle upper and triangle lower. So for that, we are going to create one tensor first. So we are going to say B is equal to torch dot tensor, and I'm going to actually create the tensor manually. And for that I'm going to use numbers, simple numbers: 68, 28, 98, 62, 34, 65. All these are various numbers that I am going to use, and I think I have 8 numbers. I will add another 4 numbers: 63, 12 and 32, and I am going to make it as d type of torch float 32, and I am going to execute it. So this is if you look at this shape or size of this tensor, you will see that it is a single dimension tensor. If we want to modify this into a multi-dimension tensor, there is one function that is called as torch. So we have to use the view function. So for that we will be using b dot view, and we know this is a size of 12. If you have to create a square matrix, or if you want to just create a two-dimensional matrix, we can simply use -1, 4. So I am going to create a 3-row 4-column tensor, and I am going to execute this. So you'll see this is a 3-row 4-column tensor. So we can use the view method on the tensor. Next, we are going to modify everything above this diagonal. So in case of this particular rectangular tensor, where is the diagonal? So diagonal can be anything. So this is also a diagonal: 68, 34, 12, 28, 65, 32. Both are diagonals, right? So what if I want to change all the numbers above this diagonal, 68, 34, 12 to zeros? Can this be possible? Yep, it is possible. For that, we are going to use something called as triangle upper. So I am going to say try C, and I am going to call the function inside the module torch called try upper. So once I do this, try upper, here it is going to ask me the tensor, the input tensor, and it is going to ask me the diagonal. Here you can already see that input has to be tensor and the diagonal has to be int, the diagonal to consider. And there are lots of options, lots of the examples that has been already provided here. You can actually look at it. I'm going to give the input as C, and I'm going to give the diagonal as 0. Diagonal is equal to 0. So this is the first diagonal that I'm going to do, and you will see that, okay, I used triangle upper here, so I have to use triangle lower. Anyway, let me change that. Because triangle upper is the next thing that I wanted to show you. So let me do that, and you'll see that everything above this diagonal 64, 34, 12, 68, 34, 12 has been made to 0. What if I have to do it for 28, 65, 32? Everything above 0, above 28, 65, 32 to be 0. So for that, it's pretty simple. I have to just change this diagonal to 1. And once I do that and execute this, you'll see this is 0. Okay, what if I do diagonal 2? What will happen? So only the diagonal, this will be the diagonal then. That is 78 and 76 will be the diagonal. You see this, 78 and 76 is the diagonal, and this becomes 0. If I do the opposite way, so if I am, instead of using try lower, that is triangle lower, if I do a triangle upper, then the opposite thing happens. So everything above this diagonal, that is above 78 and 76, that is retained, and rest is all becoming 0. And this is how the triangle upper and lower works. You will be needing this triangle upper and lower as we start working with masking fill. So we will be diving into that in a couple of minutes. So that is one of the things that I want you guys to keep in mind. Apart from this, I also want to introduce how to work with data from the files. For importing data from the files, we can actually use NumPy ND array, not Torch directly. So there are a couple of reasons for this. Most of the data that is available in the wild right now is mostly NP, that is NumPy ND array, and you can use the from NumPy method or function in Torch to convert the ND arrays into torch. Let's dive into that process. So before we dive into that process, I want you guys to take a look at the file that I'm going to use. So this is a file that I'm going to use, and this, as you can see here, is a CSV file. You are actually looking at let me actually change. Okay, so here, since we are opening it in Jupyter Notebook, it directly opens as the table here. But if you want to look at the exact file, let me go here and let me show you the file, just to ensure that let's go into practice and data file for torch. So this is how the file looks. So this is a comma separated numbers, that is 2 rows of comma separated numbers. Okay, let's now move back to this. What we are going to do is we are going to import numpy. So we are going to say import numpy as np, and then we are going to use a numpy function for this. So the numpy function that we'll be using is called as gen from text. Let's do a npa, that is the array that we are going to use, the name of the array, nd array, and we are going to say np gen, same like how we are how we can get the functions in torch. We can get it by using the tab key for numpy also, and if you do a shift tab, you will be able to get the various options that is inside the function. So we have to provide the file name. The file name is data for, just a minute, so data file for torch.csv. For torch, the tab completion for the file name is also available. You can use that. And next we need to call the delimiter. One of the important points when working with Python is that you need to know when you are going to use the named parameters and when you can use the named arguments and when you can use the arguments without names. If after the file name, if I am going to give the class name, like if I am going to say np dot float, this will work, so it will not be a problem. But in case if I use the delimiter, then what will happen is it will create an error. So now this is not going to be a problem. Even now there will be a problem because the comments is going to be hash, and after that the delimiter comes. So I need to still have one more comment data here, and then after that I need to have the delimiter. In order to avoid these kinds of challenges, what you can do is you can simply give the name, and you can say equal to comma. Once you do this, then the nd array will get created. So this, you see the nd array has been created, and if you look at the shape of it, it is 2 rows and 6 columns nd array. And next what you are going to do is np, so torch a, let's say np torch. And in order to get the tensor created from the numpy array, you have to use this from numpy function in torch module, and you need to provide, as usual, you can take a look at this data that you need to provide. Here it's simply the nd array that you need to provide, and npa is the nd array that we are going to provide. Once you do that, the torch object will get created. So you'll see that tensor object, that is of float 64, gets created by default. But what if you don't want float 64 and you want to have only just the simple float 32? So if that is the case, then you have to give the data type. Not here, you cannot directly give the data type here. You have to convert the nd array itself as type, and here you need to provide the data type. So that's how it works. So you need to change it here. I think it will actually raise an error. Okay, so it did not raise the error, and you can see that here it is not providing the torch, so it's not providing the type. So let us see what is the type of the np torch right now. You will see it's just a float tensor. And this is how it works. You can actually give the data type as you import the int array. We have seen the most important methods that we have to use for getting the data into the uh, tensor and working, so that we can work on it in the work on it and do manipulation. So let us go back to the presentation. So here we have almost completed all these functions, and we will be looking at the various transformations like mac multiplication, masked fill, cat stack, multinomial, and all these functions in the next video. Till the next video, stay tuned, and importantly, try to work with the Jupyterlab and try to install it. It's just 4 to 5 commands that you need to execute, and try to get a server and connect to it using the browser. That's first thing. And next thing is try to work with the various commands that we saw here. Most important thing is try to spend at least 10 to 15 minutes, sometimes even half an hour if you get stuck with any of these methods, and try to see the data day in and day out, at least for 1 week. After that, it will become way more easier for you to work with these manipulation methods and functions. So see you guys. Have a great time.